This is a video for AQA Mechanics, Impulse and Momentum section 1.3, where we're looking at conservation of momentum. So I'd like to consider two particles that are moving towards each other and they're going to collide with no external forces acting. If we consider the point of impact, then each of the bodies experiences an impulse, and these will be equal and opposite. Now, because impulse is equal to change in momentum, we have equal and opposite changes in momentum. So in total, therefore, because momentum is a vector, we have that total momentum must be conserved. Now we can express that in an equation, a momentum equation. And the momentum, remember, is mass multiplied by velocity. So if we have initial velocities u1 and u2 and final velocities v1 and v2, then the initial momentum equal to final momentum is simply given by this equation here. So that's the conservation of momentum equation. And it's this equation we're going to be using in some examples now. The first example concerns two masses 3 kilograms and 2 kilograms moving towards each other at 4 meters per second. They then coalesce. Now coalesce means that they're going to stick together and move as one body. So that after the impact we have in total 5 kilograms moving in some direction. Now we don't actually know necessarily which direction it's going to be moving in, but let's assume that it's moving in this direction, and we'll take that as being our positive direction for the calculations. So that the momentum before impact, the m1 u1 plus m2 u2, will be equal to the total momentum afterwards. So we have then m1 plus m2, the total mass, multiplied by v. So putting in the numbers now, 3 multiplied by 4, and then plus 2 multiplied by negative 4, because the 2 kilogram is moving in the opposite direction, the negative direction, must be equal to a total of 5v. And that gives us 12 minus 8, so 4 is equal to 5v, and therefore we get that v is 4 over 5, or 0.8 meters per second. In the second part of the question, we're asked to find the magnitude of the impulse on each of the masses. Now the impulse, of course, are going to be equal and opposite, so let's consider the impulse on the 3 kilogram mass. We know that impulse is change momentum, so that the impulse is mv minus mu, and if we take that as being the positive direction in its initial direction, we therefore have that the impulse is equal to mv, which is 3 multiplied by 0.8, the final velocity, and then minus 3 multiplied by 4, the initial velocity, and that gives us negative 9.6 Newton seconds. So therefore we've got the impulse on the 3 kilograms is equal to 9.6 Newton seconds to the left, or we could say in the opposite direction to its initial motion. And the impulse on the 2 kilogram must be equal and opposite to that, so it would be 9.6 Newton seconds to the right. In the second question, we're asked to find the speed of the 2 kilogram, of a 2 kilogram mass rather, in a different impact this time, starting off with the 4 meters per second towards each other, but this time the 3 kilogram mass ends up moving at 0.4 meters per second in the same direction as it was initially moving. So we were asked to find the speed of the 2 kilogram mass. Let's assume that it's moving to the right, and therefore taking that as being our positive direction, we can use our momentum equation to give us that 3 multiplied by 4, that's the initial momentum of the 3 kilogram, plus 2 multiplied by -4 must be equal to the final momentum, which will be 3 multiplied by 0.4 plus 2 multiplied by v. And if we calculate that, you'll find that v is equal to 1.4 meters per second. So in other words, it's moving at 1.4 meters per second, that's its speed, but it's moving in the positive direction, the direction of the initial motion of the 3 kilogram mass, so that the 2 kilogram changes direction from going in 4 meters per second to the left to 1.4 meters per second to the right. Well, in the final question, where we this time got a 2 kilogram mass moving at 6 meters per second towards a stationary mass which moves off at 4 meters per second after the impact, whereas the 2 kilogram mass, it comes to rest, and we're asked to find the value of m, the mass that is initially stationary. So again, our conservation of momentum equation is here, so we can write down that the initial momentum is 2 multiplied by 6, and then the m kilograms is 0, so we could write it as capital M multiplied by 0, and that's equal to the 2 kilogram multiplied by 0, that one comes to rest, and plus the mass m multiplied by 4. So we have 4m is equal to 12, and therefore m must be equal to 3 kilograms. Well, that's the end of this video on conservation of momentum. In the next one we'll be looking at momentum and impulse in 2 dimensions. So far we've been considering 1-dimensional cases in a straight line. We'll now go on and consider what happens if we're in 2 dimensions.